Hey guys, welcome back to AlgoYogi. We are now doing graph series, and our next easy problem in the list is find the town judge. Let's go to problem on LeetCode. So in a town there are n people labeled from 1 to n. There is a rumor that one of these people is secretly the town judge. Now if the town judge exists, then there are these three conditions that should satisfy. First is the town judge trusts nobody. Everybody except the town judge himself or herself trusts the town judge. There is exactly one person that satisfies properties 1 and property 2, and that's because the town judge themselves, they're not allowed to trust themselves. Okay, so now we are given this array trust, which has these pairs where pair A and B representing these values, these are the people, where this A and B, one pair means that the person labeled A trusts the person labeled B. Okay, so if a trust relationship does not exist in trust array, then such a relationship does not exist at all in the town. So if by the way, we need to return the town judge. We have to given these inputs, we are given the number of people and this trust array, we need to return who is the town judge. And if the town judge doesn't exist, by the way, it has to be one person who is the town judge, and if that person doesn't exist, then we return -1. So okay, so this is an interesting problem. This is a graph problem. Let's go over it. We are given n people from 1 to n, and then if the town judge exists, then town judge trusts no one, everyone trusts town judge. So basically if we go over our very first example right here, so let's say this is my town, and there are basically 3 people in the town. If you see this value 3, so number of people 3, so I'll just throw these people, so person 1, person 2, and person 3. Now let's go over the trust. So here you see, if you see that first value is 1 3, so this is my A and this is my B, so this is my A and this is my B. That means A trusts B. So 1 3 means that 1 trusts 3, then next value, this is my A, this is my B, and if you see 2 trusts 3, so there is an outgoing edge from 2 to 3. Now let's go over this graph that we just, little cute graph that we just created right here. So there are 3 people, and there is this outgoing edge from 1 and 2 to 3, and there is no outgoing edge from 3 to anywhere, but 3 has 2 incoming edges. So if there are 3 people in the town, then let's say if 1 is judge, that means then this person is trusted by 2 other people, because this person cannot be trusted by himself. So since we definitely know 3 is the town judge, that is why there are 2 people, this one and this one, these 2 people are trusting 3. So 3 is the town judge, but only if there is no outgoing edge from 3 to anywhere. There is no outgoing edge. Okay, so that is why here the answer is 3. The answer is 3. 3 is the town judge. So what we are going to do is we will have two dictionary to create 2 relationship first, and for all the people that we will be doing, for all the people, first is trusted by and trustworthy of that person, or like trusting and trust by. So we're going to create 2 dictionary. So let's say in this example we will be having these 2 dictionaries. So first is trusted by and trusting. So these are the 2 dictionaries that we'll be having, and then we iterate over our trust. Then each dictionary will have basically all these 3 people. So 1 2 and 3. Now if we go over these, then we know that 1 trusts 3, and 3 is trusted by 1. So 3 is trusted by 1, so there is one person right now trusting 3, and 1 trusts 3, so this one is trusting 3, so it trusts 1 person. Then we go over here, 2 is trusting 3, so that means 3 is trusted by 2, so 3 here is trusted by 2. Now this one becomes 2, because I will just write it like this, then it becomes easier to understand. So there are 2 people trusting 3, then this 2 is trusting somebody, so we don't care like about who is trusting, but it's trusting, so that's why this 2 will increment right here. Now in both of these dictionaries, I am trying to find the person that has the value, the key that has the value n-1. So in trust trusted by, I'm trying to find a key that has the value that is n-1. So n-1 is 2. So here this is 2. By the way, this was 2. 1 plus 1 is 2. This is true. If this is true, and now because I found this key, I have to check that in my trusting, because if this were to be the town judge, this person should not be trusting anybody. So if this is the town judge, then I'm going to check once more that if this has the value 0 right here. So if there was nothing right here, it means it has 0. So these are all zeros. And if these two are true, then only we are going to say that this is the town judge. Otherwise, we can add one more thing right here to one more example right here to understand the problem better. So let's say why do we need these two dictionaries? Why can't we just have one dictionary and just check if there are n-1 people trusting one person? So let's say we have same number of people, but just we have added one more trust, that is from 3 to 1. So let's see how that changes our situation. So in our town now we can have same number of people. So same number of people, 1, 2, and 3. But in terms of edges, 1 trust 3, 2 trust 3. Now 3 trust 1 as well. So now here is the tricky part that we have to consider. So basically we were having two dictionaries to basically calculate the trusting and trusted by. So like now in this case, let's say if we have trusted by dictionary, trusted by, so you're gonna see that in our trusted by we were supposed to have all the people, so 1, 2, 3, rest everyone other than the town judge, everyone's supposed to have 0. But in this case you'll realize that 3 has the value 2, 3 has 2 incoming edges, and 2 has 0 incoming edges here, and then 1 has 1 incoming edge. And that means that 3 is no longer the judge. 3 is no longer the judge. Why? Because there is one more person in the town. There is one more person in the town that other people trust. So and that person could be somebody else. That could be somebody else. But what if that person is 3 itself? That person is 3 itself. So I think rather than having two dictionary, we're going to create just one dictionary, and that will be, now I'm thinking about it, so that we will be having something called trust score rather than trusted by and trusting. We're going to have trust score. So and trust score will have the values. Basically, if we go over our trust, so initially we have these people with 0 trust, basically nobody trusts them. So these are the trust score. So if we go this 1 trusts 3, 1 trusts 3, so we basically increment the score of 1 by 1, and then 3, because 3 is trusted, sorry, 1 trusts 1 trusts 3, so we will decrement its score, so it becomes -1, and then 3 is trusted by, so we'll increment this value. Then we have 2 to 3, so 2 is basically decremented, and then 3 is incremented, so now 3 becomes 2, so plus 1, so this becomes 2. So I'm just gonna change it to 2. Now we see that 3 here is basically trusting 1, so 3 minus 2 minus 1, this becomes 1, and this becomes 0 now. So it's -1, 0, and 1. Now if we go over our trust score, we were supposed to have, the town judge was supposed to have a score of n-1, basically 2, but here is just 1. So that is by adding this edge, basically disqualified 3 as becoming the judge, basically. So, and also we got rid of using two dictionaries. I was still going through brainstorming, and I think now we found a better solution of keeping the trust score rather than having two dictionaries, basically trusting and trusted by. But now we'll have just trust score that will maintain basically the difference of somebody trusting you. That means you gain the trust score, but you trusting somebody, you lose 1 score. And the town judge was not supposed to trust anybody, so it was supposed to have the trust number as n-1, because it can't trust itself, but everybody else can trust him, and he should not be trusting anybody else. So that's why it's supposed to have the trust n-1. So we're going to have one dictionary to keep track of that. And now I have the solution in my head, so we can write it down, and let's go over it. I'm gonna zoom onto our editor and nicely slide it. Okay, so we'll have the trust score, and in our trust score, initially let's assign everybody trust score 0. So let's say every person I plus 1, because I'll be starting I at 0, so they will have the trust score of 0 for I in range, n is the number of people in the town. Okay, so for a comma b in trust, so this is trust is the array. Now I'm getting one pair at a time from the trust. So now I have A and B for like index by index will traverse through all the trust. So now I know that if A is trusting B, that means A is supposed to lose the trust. So I'll decrement 1 from its value, and B is supposed to gain the trust of A. Okay, B is supposed to gain the trust of A. So B is gaining A's trust. So plus 1. Pretty cool. Now I want to go through all the people. So for I plus 1 in range, can we do that actually? Can we do that? Let's try it. Yeah, in range what, n? Yeah, n plus 1. Actually no, I don't think we should be doing this. I was just trying it, but like we can start at 1 and go to n plus 1. So because n plus 1 is not included and we are starting at 1. That's how Python works, but you should be thinking it like that. Okay, so now we have these people. What I want to do, I want to find a person that has the trust equals to n minus 1. So in my trust score, I'm trying to find that person, which is I is that person. It will be traversing basically everything from 1 2 3 to basically n. Okay, to n. Now if this is equals to, and I think I should be checking it in the if condition. So if trust score I is equals to what, n minus 1 number of trusts, that means we have to return that is the town judge. So that person is the town judge, I is the town judge. Otherwise we return false. Not false, we return -1. Okay, so I think this is super easy. So we are creating trust score now. Not like initially I could write that solution as well, but just remember in that solution we'll have trusted by and trusting, and we're looking for a value in trusting 0 and trusted by n minus 1 also. So we combined both of them, created a trust score, incrementing for being trusted by somebody and decrementing if you are trusting somebody. So if the town just cannot judge somebody else, so that's why our town just should be maintaining its score to n minus 1 because it can't trust itself. Okay, so now let's zoom out and try it on our examples, test cases. Awesome, let's submit it. I think it should be pretty efficient. I think yeah, that's decent. Okay, let's write down the time complexity. Time complexity, guys, is big of n is the number of basically number of people. We're creating this dictionary and then we're going through the trust. So I guess it could be actually like n is the number of nodes, number of there are edges, and v are the nodes. So number of nodes are, let's say, v, and e is the number of edges. So this is where we traverse through the edges, and this is where we're traversing through all the nodes. Okay, so again we're creating all those nodes. So this is where we're creating all these nodes, and then we are traversing through all the edges. So I'm just telling you like it's v and e, so number of nodes, so that like we are following the theory as well. So right now, like if some students are watching this video, like you would know like why this v and e is always there in the theories. It's because of these two creating the nodes, or like visiting nodes and then visiting the edges. That's what we have done. And then in the space complexity, it will be big of what? Big of nodes. That's what we are storing. The number of nodes is the size of our trust score, which is our graph, you can say now. So okay, awesome. So let's go back to AlgoYogi. This was a beautiful problem. I loved it. Mark this solved. See you guys later.